This is a Math 3 summary video for the lesson titled Divide and Conquer. This is a Solidify Understanding task. The purpose of this lesson is for students to review factoring and learn polynomial long division. We've seen how numbers and polynomials relate in addition, subtraction, and multiplication. Now we're ready to consider division. Division, you say? Like long division? Yep, that's what we're talking about. Hold the judgment, it's actually pretty cool. Let's first review area models and factoring. So this is the area model for x squared plus 7x plus 10. Remember that the long lengths here represented by x, and then the little short lengths are 1 unit long. So for this to be x squared plus 7x plus 10, the area of this square is x by x, which makes it x squared. And then each one of these long skinny rectangles are an x, so there's 7 of them. And then the little 1 by 1 squares have an area of 1, so there's a total of 10 of these. So to use the area model, if we have the area by adding up all of the little pieces on the inside equals x squared plus 7x plus 10, then we can also represent the area of this rectangle by a length times of width. So the length here is x plus 5. 1, 2, 3, 4, 5. And then the height is x plus 2. So in factored form, this is x plus 2 by x plus 5. All right, let's factor this x squared minus 5x minus 36. I know that my factors are x minus 9 and x plus 4 because negative 9 times positive 4 is negative 36, and negative 9 plus 4 is negative 5. So remember these factors, they multiply to get the c value and they add to get the b value. And remember that the word factor is referring to values that can be multiplied to get a product. That means that this quantity x plus 2 times this quantity x plus 5 equals x squared plus 7x plus 10. And this quantity x minus 9 times this quantity x plus 4 equals x squared minus 5x minus 36. Now that we have reviewed factoring and multiplying, let's look at division. Factoring works great for quadratics and a few special cases for other polynomials. Let's look at more general versions of division that is a lot like what we do with numbers. Let's say we want to divide 1,452 by 12. If we write the analogous polynomial division problem, it would be x cubed plus 4x squared plus 5x plus 2 divided by x plus 2. Let's take a look at long division with these two integers. So I would take 12 and I would divide it into 14 and it goes in once. 1 times 12 is 12. Then I subtract. I have 2 and I bring down my 5. 12 goes into 25 2 times. 2 times 12 is 24. I subtract. I get 1. Then I bring down this 2. 12 goes into 12 one time. So the steps for polynomial long division are really similar and they're actually a little bit easier. So all I need to do is consider this x and this x cubed. What do I need to multiply times x to get x cubed? Well, that answer would be x squared. So then I take this x squared and I multiply it times this binomial. So x squared times x is x cubed, and x squared times 2 is 2x squared. Now I subtract. So I subtract x cubed minus x cubed. That should be 0 every time. Then I have 4x squared minus 2x squared to give me 2x squared. And I'll bring down this plus 5x. All right, now I need to see what do I multiply to x to get 2x squared. Well, 2x times x gives me 2x squared, so I'll put plus 2x. So 2x times x gives me 2x squared. 2x times 2 gives me 4x. Now I subtract. 2x squared minus 2x squared, good, those are supposed to cancel. And 5x minus 4x gives me an x, and I'll bring down this 2. X times 1 gives me x, so I'll put plus 1. And then 1 times x is x, and 1 times 2 is 2. So when I subtract, I get 0. So with my final answers, I know that 12 times 121 equals 1,452. And over here with my polynomials, I know that x plus 2 times x squared plus 2x plus 1 equals x cubed plus 4x squared plus 5x plus 2. In this case, 121 divided by 12 leaves no remainder, so we would say that 12 is a factor of 121. Similarly, since x cubed plus 4x squared plus 5x plus 2 divided by x plus 2 leaves no remainder, we would say x plus 2 is a factor of x cubed plus 4x squared plus 5x plus 2. Polynomial division doesn't always match up perfectly to analogous whole number problems, but the process is always the same. So let's try another one. So I want to determine if 2x plus 3 is a factor of 2x cubed plus 7x squared plus 2x plus 9. So I'll set up my divisor and my dividend and find my quotient. So I ask myself what times 2x gives me 2x cubed, and that would be x squared. X squared times 2x gives me 2x cubed. X squared times 3 gives me 3x squared. I'll subtract and get 4x squared, and I'll bring down this plus 2x. So what times 2x will give me 4x squared? And that would be 2x. 2x times 2x is 4x squared. And 2x times 3 is 6x. 2x minus 6x is negative 4x. And I'll bring down this plus 9. Now what times 2x will give me negative 4x? That would be a negative 2. Negative 2 times 2x is negative 4x. And negative 2 times positive 3 is negative 6. Now I'll subtract. So positive 9 minus negative 6 is a positive 15. So this has a remainder of 15. So let's think about different ways I can express my remainder. If we take a look back at what happens when you divide 3 divided into 10. Well, 3 goes into 10 3 times, and 3 times 3 is 9, and you subtract and you get 1, so you have a 3 with a remainder of 1. You could also write this as 3, and you put your remainder over your divisor, 3 1/3. So here I have x squared plus 2x minus 2 with a remainder of 15. And I could write this as x squared plus 2x minus 2 plus 15 over 2x plus 3. So 2x plus 3 is not a factor of 2x cubed plus 7x squared plus 2x plus 9 because there was a remainder. There is one other way I could represent this work. When I divided 3 into 10, I know that 3 times 3 plus this 1, so this 3 times this 3 plus 1 equaled 10. In the same way, I can write 2x plus 3 times x squared plus 2x minus 2 plus 15. Now let's take a look at another example. Let's divide. All right, first step, what times 2x gives me 6x cubed? That would be 3x squared. So 3x squared times 2x gives me 6x cubed. 3x squared times negative 1 gives me negative 3x squared. So be careful when you're subtracting. I personally like to write the subtraction sign by each term, so that way I just have to look down. Some people, they just write subtraction here and they'll put parentheses around it. That's fine. Or they'll just change the signs of everything. Change this to a negative, make that a plus, and then just add down. That's another strategy. So if we do it this way, then I have negative 11 plus 3, I'm still going to get negative 8x squared. And then I'll bring down this minus 4x. What times 2x gives me negative 8x squared? That would be a negative 4x. Negative 4x times 2x gives me negative 8x squared. And then negative 4x times a negative 1 gives me a positive 4x. And then I'll subtract. Negative 4x minus 4x is negative 8x. Bring down this plus 5. Then I ask myself, what times 2x gives me negative 8x? That answer is negative 4. Negative 4 times 2x is negative 8x, and negative 4 times negative 1 is a positive 4. So when I subtract these, I get a positive 1. So that means I have a remainder of 1. So I'll write this as plus 1 over 2x minus 1. So my remainder over the divisor. I can also write my answer as 2x minus 1 times 3x squared minus 4x minus 4 plus 1 over 2x minus 1. And then as 2x minus 1 times 3x squared minus 4x minus 4 plus 1. Both of these expressions are equivalent to the 6x cubed minus 11x squared minus 4x plus 5. So in summary, polynomial long division, very similar to the long division that you learned in elementary school. There are also several different ways to write your answer. Just as if you wanted to divide 5 into 11. 5 goes into 11 2 times with a remainder of 1. So you could write your answer as 2 remainder of 1, just like for this polynomial, we could have written the quotient as 3x squared minus 4x minus 4 with a remainder of 1. We could also write our quotient as 2 and put the remainder over the divisor, so 2 1/5, just as we did right here with this quotient, where we have the remainder over the divisor. Keeping with our similar ways of expressing our answer, we could write this as 5 times 2 1/5 equals our 11. Or we can say 5 times 2 plus 1 equals our 11. Alright, that's it for this video. Thank you for watching.